Let's start with company update.
Everyone's here. Great. Yeah, so I've kind of been thinking like there's no reason that we should own we can make our own demand basically. Like there's no reason that we should own only if we really have the cheapest flops, there's no reason that we should only own part of that stack. Why don't we own as much of that stack as possible? So there's a huge marketplace on Open Router for tokens. I think that this market is going to grow massively in the next couple of years. I think that's a pretty generally accepted thesis. You can look at all the people lining up to install OpenClaw, and like, look, even if it's fake, um, the world market for tokens is about to explode. So tokens are kind of like you can think about all the places. So Tinycorp right now, if you buy a Tiny Box Red, that's actually the cheapest flops per dollar you can buy. And but that's only like why stop there, right? Why would we not also host that tiny box for you? And then why stop there? Why would we not run the application that you're going to run on that tiny box for you? And if you're just going to end up running an LLM, we should be selling you tokens. Now, I'm not saying we don't sell the other things. We sell all of them, but we progressively make more margins. So like computers are a 20-30% margin business. Hosted computers, 50% margin business, tokens, 70-80% margin business potentially. So what do we need in order to do that? We need basically a competitive, a globally competitive, cheap place to plug in tiny boxes. Then you start asking, okay, what scale should we do this at? So Comma's been operating at the 500 kilowatt scale for the last couple years, just kind of finally filling that data center up. At what scale does so you don't want to do it at 500 kilowatt scale because you have fixed costs. You got to get security for the building. You got to get maintenance people up there. Whether you're driving a truck, doesn't matter how many computers you put in it. So the question then is like, where is the next scale breakpoint? Where is the scale breakpoint where you can still fit all the computers in one truck? Where your cost of security and stuff is amortized? And the answer to that is probably somewhere around 5 to 10 megawatts. So 5 to 10 megawatts costs about $1 million a megawatt to fit a site out the way we're going to fit it out. We're way cheaper than everybody else because we're not doing tier 3 data center stuff. You look at the cost of colo and it's astronomical. I went to Washington last summer and oh my God, these people want 30 cents a kilowatt hour to run your things. I mean, we're literally running it at the same price in San Diego. And that's not even like they have like all these fees they tack on and stuff. It's just it's awful to deal with these kind of people. And the reason they can act that way is because over valuations that are overly inflated and AI companies have come in and basically pre-bought all the capacity. But there's a great way right now to get capacity, and that is Bitcoin mines. So Bitcoin right now is low. Bitcoin mines are underwater. There has never been a better time to buy up a Bitcoin mine, get it out as a tier 1 data center. We're not going for tier 3 here. 99.9% of uptime beats Claude. So yeah, build out a tier 1 data center, have everything ready to plug in 5 to 10 megawatts of stuff the second the unit economics make sense. And then as soon as the unit economics make sense, we build tiny boxes, not for customers, but for ourselves, and then sell the tokens on a marketplace like Open Router or something competitive. That's basically the pitch. We're raising $20 million on 200 million. Our last round was 5 on 50. Since then, we've built a product and shipped it. We have a $2 million contract with AMD. And we've made tons of progress on TinyGrad that will actually enable us to start to be able to use this cheaper hardware. The way that we're going to beat everybody else in the space is 2 things. 1, we don't build tier 3 data centers, we build tier 1 data centers. And 2, we don't buy NVIDIA chips that already have the entire margin baked into them. If you're buying an H100, if you're buying a B200, that chip has 80% margin. You can't make money. it's already gone, right? So we want to buy chips with 30% margin, and then take all that margin for ourselves basically, because tokens and flops are a commodity. Tokens really are a commodity. Nobody who's buying a token on OpenRouter cares if that's an AMD token, NVIDIA token, or a Samba Nova token. So yeah, commoditize the pay to flop, at every scale we possibly can. So that's the raise. I didn't get much sleep last night, being on the phone with people. But that's the pitch.
We expect it to close.
Uh, yeah, we have lots of people who want to give us money. It's a question of who we want to take money from. You know, yeah. So when do we expect it to close? I mean, realistically, I'm back in America in April. It's probably not going to close before that.
Any questions for people in this meeting? Right here. Start the pitch. Feel free to post in general channel, and while you are doing so, we can continue with our agenda. Started with llama training.
I don't know how stable my internet is. My current download speed is 100 kilobits per second. I hope it's working.
Can't hear you if you're talking.
So it's not working. Is it better now? Hello?
Try now.
Working?
Yep. Did you hear us?
Okay. Yes.
All right, great. I don't know. This is what happens. Discord went public or something, and now it doesn't work.
I don't know. My internet is really bad right now. I'm getting like 93 kilobits per second.
Oh, okay.
So it might be on my end.
We're gonna have a
llama
we're
training
gonna have a
is
4OP step this week.
yes, we're gonna have a 405B step this week. A lot of
Right.
stuff I saw was merged over the weekend, even though I didn't have time to fully look at it. I need to test Chenyu's partial assign fix for Fuse Optim. And I saw that Nimogen merged copy memplan. So I think memory might be good. But Nimogen, does your copy memplan fix thing, if I copy to a device and then I immediately copy from that device somewhere else, does that buffer get memory planned?
Yeah, I mean, all buffers are memory planned right now.
I see.
I think, yeah, it should. At least the test you pushed, it passes right now. I mean, with several layers.
Okay.
So you actually got it to work. How did you synchronize it?
What do you mean? How do you synchronize it? I mean, we just, yeah, the only problem, the only dependency we had is then we have like copy, then it just goes to compute, and then again copy. And basically that's the only dependency we want to get rid of, because I mean the second copy can simply can remove like the buffer from the first copy, and because of that, because of the compute in the middle, they will be sync across the compute and copy, and you cannot do two copies. And
Yeah, I mean, as long as you're just making sure you synchronize before you fill the buffer up, because this can, and like the reason we didn't memory plan copies was this. Like the device, are we pulling or pushing on copies?
We pull in.
We're pulling. Yeah, pulling's probably easier to think about for memory planning. I mean, if we're pulling, we just need to make sure that the minute we start pulling, the thing is there and it hasn't been overwritten by something else, actually. That's the problem.
Yeah, I mean, that's definitely. I mean, we have access resources and all these dependency tracking inside the graphs. So it should
Right.
track all these accesses. Yeah.
As long as you're confident it's good, because the danger is that you start pulling something from GPU 2, and then GPU 1 runs a compute kernel that overwrites it.
Yeah, I'm pretty confident. We had some bug with our AM driver, but yeah, I'm confident. I'm basically did llama training and other trainings we have, and actually the loss was the same with the fixed seed.
Right?
Yeah.
All right, what else we got on 405B?
Is there a command somewhere that we can just maybe run with now and see what's the current number or memory?
Yes, if you can just for memory.
Yeah, can you just post it? I'll run it later.
Yes, I'll post the command.
Yeah, because then other people can also try that. See if it applies for the copy thing or whatever.
Yeah. I will do that later at the airport because where I'm at right now, the internet is really bad.
I want to again reiterate the importance of the AMD contract. The importance of the AMD contract is that another way that we can be more competitive than anybody else is that if we can get AMD to give us a good deal on RDNA 5 cards. It's important that we do a good job on this relationship. I'm going to go speak at their thing, and I should reply to their thing. You know, they want me to go speak at their thing. This relationship is very important to us as a company, and it could potentially be something like a $5 million swing. You know, even more than the value of this contract. So, yeah. We have to get one of these. We have to get one of the 4 or 5.
Yes.
All right. If we get a step this sprint, we're looking good.
Yeah.
Are we?
We get a step? I think so. Yeah.
It will take a month.
I'm pretty confident that we can get a step. It might be very slow, but
Well,
I'm
why?
confident we can get a step.
Okay, let's get a step first.
Let's get a step first, and then like, why is it?
Let's
So
get a step first, and then we can figure out why it's slow.
I'm confident in our look. If we don't have to do too much like gradient checkpointing, I'm confident in our jam and flash attention being fast. I'm confident in the gradient offloading thing can be rewritten so quickly if that's at all an issue. So I'm not worried about that. I guess I'm only worried about it fitting in memory and not needing to do too much gradient checkpointing. It's like too much gradient checkpointing.
Yeah, I do think we need to do a bit of gradient checkpointing.
It depends on how much. How much are we recomputing, right? If we're recomputing nothing, we have high throughput kernels. You know, everything's good. But
Let's resume this discussion after we have a step that fits. And
First thing is fitting a step.
that sounds good. Just post the comment somewhere. Go from there. Let me know if you hit other assign issues or item issues. Don't like bufferizer.
Yes.
Bufferizer assign has so many hacks. I just replaced one hack with a better hack.
right.
Okay, sounds good. Okay, next is this.
Last week, I spent a lot of time looking into real time, putting seconds in the SKTT. It's
Haven't tried.
almost done. It's almost done. It's in the branch for RDNA. And yeah,
Have you changed the names over to the official ones?
I am starting to do that. Yeah, The names are actually some of ours are better.
No, ours are definitely not better. Why do you think ours are better?
Yeah, there's some like bit 8 that's like just bad. Some for ops are nicer. But I've changed most of them, especially for RDNA 4, since those were wrong.
Okay. If you
Yeah.
want to say they're nicer, really like at least have a comment with AMD's name.
All right, yeah. So like the ones that I'm mentioning are like, so we call it, for example, VLU WAME, and they call it VLU 4 or something.
Yeah, look,
Like,
yeah, I'm okay with that if you just have a comment about how it's VALU4. It also somewhat seems like that repo might have been stripped of some real stuff, but
oh, it's definitely stripped of some real stuff. I don't see ALU exec or VLU exec at all mentioned.
which is crazy. I didn't see those either. Did you figure out how? I mean, it is working for their stuff. That stuff has to be using the ALU execs and the VLU execs, right?
No, it's not. It's patching. So everything that's about like the quote unquote duration and stall stuff is like in the stitcher layer later. That's like patching from the ISA. That's why when you put vnob after and after over and over, you'll get like right timestamps but wrong everything else.
Wait, but is that true in the real Rocktrace profiler too?
Yeah, I read the code. It's like when you put
I wanna know,
vnob, it
is it
gets
true in the closed source one too?
the closed source one.
Yeah.
Oh, you mean compare the open source and the closed source? I see.
I'm saying
All right.
is the closed source one using VLU exec or not? Because yeah, I thought that it was weird that they didn't have it.
Yeah, I didn't check that. I have to.
Yeah,
And
I
it's
mean,
weird that they don't have it.
yeah, I mean they might just get the stall with the dispatch, but you know, I agree it's weird they don't have it. I don't know. How's CDNA Viz coming?
Oh god, CDNA is I'm working on it. It's complicated. I mean the timestamp patching stuff.
Yeah, I don't really care if it matches perfectly. I saw your algorithm reimplementation of what they were doing. Look, if it's a few cycles off, I don't even know if their thing's correct.
Same. Uh it doesn't, so there's like a packet that's like patch this, and then you have to buffer a bunch of waves. You can't like yield the packets as they come, and you have to like buffer them in memory. I'll think
I
about it.
Yeah, I don't think we should have all this complexity. I think there's a chance that our stuff is just better than theirs. Uh,
Same.
just yeah, draw the real stuff.
I'm also interested in seeing if CDNA has an exec because I only saw issue in CDNA. So there's like an issue and then there's a confirmation of that instruction, but there's no like exec, like value exec, which I'm suspicious of. There might be like an undocumented one again because
Well,
ALU
yeah,
exec wasn't in the
yeah, they
code.
didn't document the RDNA one, so I would guess that CDNA has one that just isn't documented. How'd you get the clock speed for real time?
Read the bias and also sampled the registers from MIO to confirm it.
Okay, you confirmed it. You did something to confirm it, and it really doesn't change.
Uh, so the clock speed, the RLC, does not change. It's set in the bias to 100 megahertz. The shader clock might change, which is, I think, the reason why RDNA gives you a stream about every 4,000 cycles. It's recalibrates. CDNA doesn't, interestingly, but RDNA does give you a calibration.
CDNA. The whole thing is real time. Yeah, you know, I know the packet you're talking about for RDNA. Okay, cool. So that thing runs at 100 megahertz. Yeah, makes sense.
Yeah, the reference clock like runs at 100. The other one is pretty stable. Like if you plot it, it's linear. It's perfectly linear, but I don't know if
You left the
there's a
cycles
way
in
to
too, right? It has
plot
both
it.
the cycles and the real time.
So the real time, yes, it only has the last 36 bits of the real time.
Yeah, but my point is the bar should have both the cycles and the real time because the shader clock might change.
Yes, the shader clock might change. It doesn't, but it could. Yeah.
But yeah, so this sprint, finish up real time and CDNA and using as many AMD names as possible.
Using as many AMD names as possible. Yeah, makes sense. We'll get to CDNA more. I see that your decode loop supports both the CDNA, supposedly, because it's not packets based, right? It's bytes.
It is packet based. AMD just doesn't understand that it is. The loop supports both. The RDNA one clearly was developed after the CDNA one, and they talk about the CDNA one differently. But the RDNA one is flexible enough to encapsulate what the CDNA one is. We shouldn't have two decode loops. I know that their repo talks about this differently, but they just didn't understand what they were doing when they wrote the CDNA one. It's the same.
Oh no, probably sample some real stuff. See if the timestamp patching actually makes a difference.
Yeah, as long as it's close, it doesn't matter.
Yeah, I'm also like briefly considering putting all the structs in AutoGen. It's not going to be easy because the code is in C++.
I don't think that's worth it.
Just copy it.
Yeah, I think they're simple enough that we just write our own.
Right.
Yeah, they're not. They're simple. There's only like 12 of them. And one of the other distinctions is why I'm okay with not using AutoGen for this is you have to ask the question, is this in software or hardware, right? So for something like libc, obviously we have to use AutoGen because libc can change. Even if libc doesn't change, it's a software package, it could be updated. Not like AMD can update the RDNA 3 SQTT packets.
I think they can.
How?
Microcode update?
With what?
Microcode?
No, not
They
microcode.
can't?
I don't think-
Yeah, I don't know.
I strongly doubt they could update it.
Yeah, the reason why I think it is because real time is actually a pretty new thing. But maybe the decoder is a new thing, and it exists as the packet for that.
Yeah, I'd be very surprised if they could update it. But I'm curious if there's any evidence that they can, but I doubt it.
I'll look at it because I am suspicious of one packet update.
Yeah, the side thing on Viz looks nice. I would just try to fit those on one line if you can, like with the address and the instruction.
I can't. I tried. I know, like,
You have a lot of zeros there. You don't need them.
so you actually do because your PC can get larger and it gets ugly.
I don't know. Whatever. You think about this later.
Yeah. I broke it into 2 lines. I think 2 lines is reasonable.
No, it's too many lines.
Okay. uh, 2 lines. It's. I mean, the sidebar is tiny. So we gotta like.
Yeah, you drag it, make it bigger. That's so many lines. All right, cool. Yeah,
Yeah.
you think about it later.
I'm thinking about it more. Also, there's a backtrace in the user device. Now I know you asked for that.
Ooh. Yeah, so you
Yeah.
mentioned that. Yeah, that's nice. That's great.
Yeah, you'll see it in exactly the call that's in exactly the tensor call that created whatever that thing was.
Yeah, that's nice.
That's all for me.
Sounds good. Next image one.
Wait, skip drivers.
Sorry, my bad. Drivers.
Yeah, so memory issues should be fixed. So speed on HVAC also was fixed. And also a merged refactor. You asked for, George. I removed ops and deck.
And now we have ops custom function.
Yeah.
No, I think ops custom function's a lot better. I briefly read the refactor. So confirming that custom function is like source zero of a call, right?
Yeah.
Great. Yeah, I mean, I think that hopefully that this API makes sense for all things that look like EncDAC. You can put anything you want in custom function. In fact, there's even a world in which copy can become custom function. Maybe not copy in the big graph, but as soon as we like lower copy to like right, like the custom, like SDMA could be a custom function. That makes sense.
Yeah.
We think it's better to keep a copy.
So
Do you think it's better to keep copy as like the way that it is, or switch it to like custom function, like SDMA?
I don't know. I mean, I think it's fine as it is. But actually, I mean, semantically, it's like, yeah, it's the custom function.
Yeah.
I mean, it's the same idea as EncDAC.
The other advantage to using custom function is then we could use both SDMA engines.
Yeah.
I don't know. It's just an idea, but yeah, cool. We'll talk about it when you get here.
Yeah, and I mean, for the memory, for the new memory planner, so I ported it as a rewrite rule. So and actually it works in schedule, but I think we need JIT 2.0. So to have the same memory usage in JIT. So basically, because we have like several realizes,
Yeah.
and we can have several realizes inside JIT. Yeah, that's the main problem. Like either we keep 2, or we have some problems with memory usage.
Yeah, I think before JIT 2, I mean, I think it would be pretty easy to kind of like we can mess with the realize. We can like not do the realizes if you're inside of TinyJet, like even with the JIT we have now, and just pen the realizes till the end. I think I call it like qualify or something. We can basically do the realize inside the JIT, but it would still stay in the graph.
Yeah.
Like we lower it to the point that it's the linear and then. I don't know, or we could just, yeah, like rip off the Band-Aid and just get JIT 2.0 working. I don't know. No, I think like it's a worthwhile step beforehand to blacklist the use of realize and JIT.
Thing is, that's what they realize.
Well, at the end, yeah. I don't know. We'll have to figure out. We have to think this through. We have to think through right now. But cool. Yeah. No, I'm glad memory planner's in the scheduler. And can the memory planner work for? I want to also move. Maybe you want to take this move define local to buffer, so that it works for define local as well.
Yeah, I can do that. Yeah.
Great.
Anything else?
No.
See you soon.
Yeah.
Next, real image one.
Yeah. Yeah, so I think the last big thing for image one is the invalid intensor. Yeah, I can explain why we need that, which is if you use a pad, then you're forced to put zeros everywhere. And like you don't want to have to write all those zeros on the extra this place you don't care about because you never read them. And so we need some way to express that you don't care about this extra data. And you could use a partial assign, but the problem is that means you need to assign into an existing buffer. And the buffer, if you don't know where the buffer is going to exist beforehand, then you can't assign it. Like if you don't already have a buffer, there's nothing to assign into. Yeah, that's the deal. I think it's all coming from this pitch add thing, where we like add a little bit of extra stuff to the pitch in the case of image equals 2, just to like it sort of messes with the alignment. And yeah, I mean when you comment out the pitch add stuff, we get the same performance in image 1 as image 2. So that seems to be where all of the performance difference is coming from. And the problem is that right now, if I add that and we write all zeros there, then you lose all the you spend all this time writing all these extra zeros. Wasteful. Why are there 2 more kernels? What other kernels? They just come from like the pad. So like the found contiguous hack that can't see through pad. And we do extra padding right now in
I see.
Yeah.
Okay.
But I profiled the difference and it's like 0.05 milliseconds. Right. So,
Yeah. Okay. So yeah, sounds like yeah, get the assign thing working. And then why is the wall time 30% more?
yeah. I mean, this is just like solving choosing which the best dimensions for the image is like really expensive. I should probably figure out a better way to do this, but right now we just like iterate over all of them and see which one removes the most valids.
Most div mods. Okay, so that's what's. Are you caching it?
Yeah, it should be cache. I can double check, but I didn't cache.
Yeah. I don't know. I think if you're running with some debug, just have it like print some stuff for that. If it does that search and like what it finds.
Yeah.
Is there any print in the debug if I?
No, but I
Yeah. But cool. Yeah. Just confirm that it's that because we can't have. We got to make that the same too.
yeah.
So we will have a pad in tensor.py that's an actual pad, not a pad with const 0. Yeah.
Yeah, you could do that. I don't know if this is like something that so the way that I was expecting people to use this is you have like your mask and you do .where and then you put your values that or invalid. But we could also expose this as like a pad.
No, because
or
our pad now is like pad with const.
No,
Yeah.
you want it to be pad with not 0. I don't want to change the semantics of pad. I do not want to change the semantics of pad. No, padding, but padding with so let's say you pad with invalid. How do you get zeros there?
Guarantee is 0. It's like you're not supposed
No.
to use that. If you want to pad 0, you just say pad 0.
What does it mean to pad count 0? How does that work? What does that look like in
So-
UOps?
But I don't know. We just guarantee that if you do that, and when you access the value, it's guaranteed.
No. Pad should definitely be zeros. So then, but it's free, right? So then what the construction looks like when you want to do the invalid thing is that you have let's say I have a buffer that's 13 by 13. I want to pad it to 16 by 16, right? So I do a pad on it, which adds zeros, but that's not what I store. After that pad to 16 by 16, I do a where with a mask and invalid. It loses no performance. It's great. But I think it's much better to keep pad semantically meaning add zeros, and then you can get rid of those zeros later. Well, let's say it's invalid, right? If it's invalid, how would you express the, how would you express cat?
It was count 0.
Yeah, how do you express pad with count 0?
Right aware.
Well, how?
What do you mean?
Oh, you want to write a where?
Yeah.
You want to have it be invalid and then do the other thing where you
Yeah.
have it do a where? Yeah, I definitely don't want to do that. Because the problem with that is,
So what kind of match how we use valid in no? Why should it be different? The pattern we currently have.
the other one matches how we use invalid in UR too, I think.
We use it as a where.
Yeah, we use the invalid as a where. Add doesn't add invalid, add adds zeros. Well, the other problem, yeah, I mean, the other problem then is like, okay, so what's the derivative of string?
Add pad 0.
I mean, add
I mean pad 0.
pad 0, right? Like, yeah, we want to keep pad as pad 0. I really don't think we want to change that, and I really don't think we want to add an argument to pad.
Yeah, the only hang up I had while I was writing that is tensor indexing. You're right.
What?
It's well, the problem is that we do tensor indexing with reduce over, like you do a sum.
I don't know. I mean, if as long as it solves your issue,
Yeah,
we it's not clear if we introduce invalid in tensor, like to what extent it should work, right? It has a weird D type. Should it work with other D type? And what do we
Yeah.
change the D type of that? And
but anyway, like I try to add a test that is like, okay, well, like say you have, you try and tensor index with something that has like partially invalid. Like a tensor, like the tensor that you're using to index the other tensor is partially invalid. It makes the entire thing invalid because you're doing this reduce, and if anything in the reduce is invalid, then the entire thing becomes invalid.
but then we start to add things in tensor.py that looks like data dependent,
Yeah,
like check your data and stuff,
Yeah.
and we really don't want that.
yeah, no, for sure, for sure.
But how, wait, I don't understand how you can raise an error if you try to index with an invalid.
Yeah, but how can you know if it's invalid?
What do you mean? Yeah, it was just when you render it. Just render it. If the kernel at the end of rendering has an invalid left in it, raise an exception.
But that's like data dependent workflow in tensor.py.
Oh, it's not in tensor.py, what do you mean? Just in rendering it. Sure, like there's some things you just can't write, right? Like if I write something that says invalid +1 dot realize, let's raise an error.
Oh, you think you should raise an error and not just not do anything?
What do you mean not do anything?
Well, okay, so like say you have like a full of invalid, right?
I don't understand full of invalid. If I create a tensor with invalid as a const,
Yeah.
and I do that +1, and I do dot item on it.
Yeah, I mean, what it currently does is it returns whatever is in memory, like that got allocated.
Well, that doesn't sound right.
That doesn't make
But
sense at all.
the thing you just mentioned also doesn't make sense to me.
Why?
Like what D type that is.
Whatever D type you want. Same as the you're
No,
adding.
no. We don't have D type index in.
It's not D type index. The invalid can be on float. That's fine. The const float with arg invalid.
Yeah, when you do this, you have to declare what D type. Like if you do full invalid, you have to declare the D type.
Okay, I don't know. It's an error. Whatever.
No, but it's actually really important what happens when you try to realize that. So the problem with trying to realize that is, okay, great. It's lowered all the way down, and you're left with const invalid in your lowered thing. If there's ever a const invalid left in your lowered program, it fails the spec check. Make the error message nice.
No, but it what it does is it pulls it into the store and then gates the store. So it's just like, okay, well,
And if you can fold it into the store, that's phenomenal. But if I have invalid +1, I can't fold that into the store.
invalid +1 is just invalid.
Yeah, and I can't store invalid.
But it gets folded into the store, and the store is always invalid, and then it turns into a no-op. And then you just have a no-op kernel. Actually, we should probably raise for a no-op kernel. That seems significant.
No, I wouldn't raise for a no kernel, but I see what you're saying. So you have a rule that takes invalid +1 and just removes the +1.
Yeah.
It's like nan. Whatever AOE would.
Yeah. Okay.
So the thing you ask can also apply to nan, and we know nan is.
No, I mean, that behavior kind of seems okay then. I don't know.
You can ask for something as if you have invalid and multiply that by 0, should we just return 0? Doesn't fail.
Yeah, I don't know.
That's the issue to have that answer.
We introduce invalid, and it has all these phenomenal foot guns that will clean up in 3 years. No, I mean, I don't know. That seems okay. I guess actually doing nothing is fine. If you're defining invalid +1 equals invalid, then
Invalid times 0.
Don't worry too much.
invalid times 0 is undefined. It may be 0 or it may be invalid.
Okay.
Sorry, don't multiply things by 0 if you wanted a good
Which is
outcome.
to say that it is invalid.
No, it may be invalid. It's undefined.
Which is what invalid means.
Oh no.
Undefined means it can be anything.
Yeah.
It can be 42.
1 plus invalid is always invalid. Invalid times 0 may be 0. Sometimes.
Invalid can sometimes be invalid.
No.
Invalid's invalid.
Anyway, okay, sounds like you have a good.
It's undefined. It's like dividing by 0 in C. Like
Okay,
when you
okay.
divide by 0 in C, sometimes you get an exception, sometimes you don't.
Okay.
Yeah, okay. No, I'm fine with it doing that. As long as there's a good justification for why, I don't think we should raise on no-op kernels.
Okay.
I think that the user can shoot themselves in their foot if they use invalid FOIL.
Invalid.
Use it sparingly. Yeah. Sparingly and carefully.
Yeah, I mean the question is like whether there's ever another use case for this other than this weird pad situation.
I'm sure we'll find one.
Once you add something, people will find different ways to use it.
Who knows what auto research is over there doing right now?
Anything else?
I think it's. I guess I should also talk about why the USB GPU stuff is slow. It is true that like partially this is slow because of like the C-type structure packing. We could speed it up by using struct.pack. There's like when Armand posted that issue, he had like a AI generated patch, super complicated. There's a much simpler way to do it, but it's still kind of like a fast path for like simple C data. So
I don't want a fast path.
okay.
We decide if we want to revert or no. Very happy with the speed.
I think they're not happy with the speed.
And will reverting this make them happy about speed?
Okay, I got to benchmark it and see exactly, but the benchmark that Armand posted that issue did not seem significantly faster. It seems like a bigger issue. And the other thing is that we spent a ton of time in memory.py in valloc. I'm not totally familiar with what all that code is doing, but it seems to be like messing about with page tables a lot. And I'm not sure. Anyway, I would have to read this a lot more to understand what exactly is going on, but I don't know if all of that is necessary. It certainly seems like we're doing a lot of virtual memory allocation.
It's working.
Well,
Oh, it's working. I'm not.
So I think probably a better way forward is making sure this seems to be important. So just make sure always like someone is on top of like something. So either we got a concrete number for they will be happy if it's something is below a certain number.
yeah.
Then we'll decide like what we do.
I'll bug Armand about that and see what he has to say about what performance targets they have. But it sounded like just in general they wanted it to be faster. So yeah,
Everyone wants everything to be
Yeah,
faster.
yeah.
Okay. Sounds good.
Yep.
Next spec. There's a link to the spec.
Yeah, I linked the spec. It's 80% of what's in TinyGrad right now. I think we're getting to kind of a point where there's a lot of things that aren't really going to change. There's a few things that it's pretty clear what the simplification path is for, notably D-types of vec. D-types of vec shouldn't be a thing. It should just be shape. Right? I mean, why is it not a shape? It should just be a shape. The call was added pretty successfully. I think that there were no real regressions or issues. I think call was a strict win. Call is really important to I wish I'd gone with call sooner. There's like a algorithmic complexity difference between I mean, I always knew this with things like stunning MNIST, but the answer to stunning MNIST wasn't range, it was call. Like call's a much easier thing to do than range. For example, if you have an LLM that has the same layer 100 times, right? You're talking about a square root difference between let's say you have 100 UOPs in 100 layers. Well, if I spell those all out, if I have a full graph, that's 100 times 100. But if I have call, it's 100 plus 100. And we always want to be getting those pluses instead of those times. I mean, that's like a core philosophical thing of TinyGrad, right? Like D types are plus. New ops are plus. They're not times. But then the UOPs themselves were times. So everything's gonna be plus with call. Yeah, so everyone should read over this spec. If you're surprised by any of it, let me know. Post about it. There shouldn't be anything like surprising. It's not radical. The other difference in the spec from what's actually in TinyGrad is the way that multi's done. So currently, when you allocate a buffer on multiple devices, it's not really clear where the multiple devices are. We have these other custom UOPs to access them, mselect and mstack and multi. But we can get rid of mselect, mstack, and multi if we instead use if we instead make the multi explicitly part of the shape. And what that means is that when you create a buffer on 4 devices, imagine if you create a buffer of size 100 on 4 devices, it puts 25 on each device and concatenates them. So a buffer is created with a sharding of axis 0, and then you do something special to get a sharding of axis none. Because none is the strange case, 0 is the common case. Think about memory in general. Memory in general, when I allocate a tensor that's 4 by 25, well, that's allocating 4 chunks of 25 all concatenated. And now when I allocate a multi-device buffer, it's 4 chunks of 25, it just happens to be across the devices. I think that works. I went through and derived all the primitives in nickel with it. So yeah, those are the 2 changes. They'll slowly make their way into TinyGrad. Hopefully everyone sees with call like what JIT 2.0 looks like. I should include some stuff about the JIT in here too. Specs still work, but I find that if I spend time in the spec, takes time on crashing in the implementation. The other interesting thing added to call is tuple and get tuple. So those aren't in there yet, but they're an exact copy of what's in XLA, and they allow call to return multiple things. You can return a tuple from call, and then you can call get tuple on the output of call and retrieve these things. Yeah, that's the spec. I'll work on it a bit more this week, but a lot of my energy's gone to the raise.
Any ops are there in total?
There's 40 in the spec.
40?
Yeah. If you don't include the cogen ops,
Sure.
exclude cogen ops, and obviously exclude decomposed ops, that's 40.
Company name is C, capital C.
TinyGrad Corp.
That sounds good. This is my stuff. I assign. I will fix any ongoing that item may assign issues. There are still 2 that I'm aware of, but I'm deciding like how to fix. But otherwise, things should be expected to work. This past week mostly works on the div and mod stuff. Now it's in a single file. My strategy. There are like some of the discrepancy between how we simplify div and how we simplify mod. And we don't really want that because we have later rewriting rules that try to recombine a div and mod together. So if in earlier steps you treat them differently, then it's a lot more difficult to recombine it later. I already fixed several of the discrepancy and open pilot with image 2. Now it's like 7% faster.
Combo, we made something faster. We made something faster. Tinycorp doesn't always get slower. Then you made something faster.
So my strategy here is trying to make the most robust and powerful div mod to like fix all the known issues, then find a way to combine and eventually make it smaller for that file. That's the div mod.
Two questions about this. So, do we want to keep both div and mod?
Do we want to keep those div and mod? I think we do. Discuss about this later.
But that. Okay, so we want to keep both div and mod as for you.
We're thinking about like always treat mod as like
You can write
minus the
Yeah,
high
yeah,
div version. I think it's similar to where and max.
Mm.
It's just have like much nicer properties to not always infer that from. Even if you could, it's like
I looked at Luminal. They claim they only have mod, but that doesn't include their shape tracker map, where they actually have
yeah,
both div and cdiv.
that's not even work. Oh, I also briefly look into. We currently have a very annoying like direct div mod.
Oh yeah, what about corrective mod? What about that great flag?
So I have a way to do that, but that's really not necessary after we remove image 2 optimization.
Right.
So for now it's there. I know how to fix it, but unfortunately I feel.
Image 1 is gone this sprint. Image 2 is gone this sprint.
That's the goal.
All right, finally. All right, gotta be
Yes.
gone this sprint.
So I'm on top of that. I'm aware of that. We will see. Yeah. So I think similar to we keep Max because Max has nicer properties. It really makes the code simpler. If you don't want to support like one of it at the end of your program, then you can just like replace it at the very end.
Yeah, the question, yeah, at the very end, all this stuff's easy. The question is like for simplification.
Yeah. So
Is
for
it-
simplification, it's definitely easier to
Okay.
do math and reason about it to have two.
Um,
So we definitely don't want the div and cdiv and like mod and cmod. Those should be like we just pick one and always use that.
yeah. It comes down to whatever's easier to reason about, right? Like I think like adding something like sub would make things harder to reason about. So we don't add sub.
We have a more -1.
Yeah, but that's a lot easier to reason about than sub, right?
No, because
Also, always keep in mind if you want e-graphs, we can add e-graphs.
I don't see why egress will help, but sure.
Well, so like, okay, so right now we added there's two graph rewrite engines now. The other one is very simple. They're the same two that are in MLIR, but one of them is a greedy replacement and one of them is called walk. And walk just tries to replace everything in the graph once.
Yes.
Doesn't iterate and change things, so on and so forth. It's actually really useful for things like substitute.
It's
And
very useful for assign because otherwise you got the infinite chain.
Yeah. No, you get these infinite loops, and then you break the infinite loops with tags, and then you have to pass to remove the tags. But yes, keep in mind if you want egraphs, like I would rather have 2 rules on egraphs than 10 rules on not egraphs. Kids would always talk about how there were like 2 magic rules for all of symbolic. If only we had egraphs. So I don't know if that's true.
So let's probably at some point we will want that, but not in div and mod.
Yeah.
For now, we have a lot of rules that do the like changing the order of an add chain to do something.
Yeah.
So maybe
yeah.
things like that already has like 10 different rules everywhere.
Yeah. So to make clear what egraphs are is like what egraphs will do is they will try you can have rewrite rules. You can have like one rewrite rule that factorizes and one rewrite rule that unfactorizes. And then egraphs will run for some fixed amount of steps. They can also run to convergence. Like there is a convergence when you don't get any new graphs. And then think about the hypergraph of all the possible graphs, and then you can extract with some limited amount of cost functions one graph. And you can do this data structure efficiently, where you, instead of needing to represent all of the graphs, you can represent them as
I think for the use case that we are
Big different.
seeing, probably fine for now. I see how we benefited from it. Now, yeah. Maybe that works if we only have not and not if or something. Because then you can think of all like that. I don't know.
I think the Luminal people wanted to do that, and then you look at their shape tracker and they have div and cdiv. So
My stuff. Up a bit. Uh, Hero was here. We don't get any comma complaint. Other issues, bounties.
Crosland, are you working on the CDNA4 emulator?
It hasn't gotten updates. I'll look more.
Yeah,
He
just
said the last. Yeah, I'm on top of it. The last thing that he said was that Asm doesn't pass.
great. Yeah, just poke him again. I think it's close. I think when he fixes Asm Gem, we can merge that.
Right.
RDNA 5.
Oh, RDNA 5. All right, we got a minute to think to read this Moore's Law is dead branded thing. What is this supposed to? It's GDDR7. And it has a memory bus width of 512. Great. Love that. It's supposed to add this. Is this real? Is this real? I mean, I'm not really referencing any specs. My assumption is just kind of like thermal passive. For some reason, their big chip is passively cool. Oh, it's made by MBA, so it's not real.
Wait, no, it's very likely that the big chip is passively cooled, no?
What?
If it's a OCP socket? If it's OCP.
You think it's OCP? Oh, you're right.
Yeah,
Wow.
if it's like in an
Yeah.
OAM socket.
What is this thing for
Yeah.
the market segment? What's co-VOI?
No.
But I see it's not segmented for desktop gaming.
Yeah.
I see. Interesting. Okay, so that's why it's passively cooled. I don't know. All right, I guess we get the one with 384 then.
I guess the problem with that is that the VRAM size is too low if it's OAM.
Oh, is that what they're calling frame buffer?
I'm assuming.
Oh, I see. Okay, cool. So they're making a 72 gig card. But I don't know. I mean, maybe I don't mind if it's OAM if it's cheap. Wait, why do you think it has to be OAM and it can't be a card?
If it's passive, no?
No, I agree that yeah.
I mean, that's just what like I go to immediately.
Yeah. I mean, you're right. If it's passive, it's got to be something. But I don't know. They have this other option with 72 gigs of RAM. I think it all works out. AMD knows what they have to make. I mean, look, even if it's just 36 gigs is kind of small. Hopefully they don't price gouge on the AI ML version. 72 gigs is fine. We just might need to build eight card computers.
Hopefully it's not going to be super expensive.
Yeah, I mean, yeah.
Okay, cool. That's it for this meeting. Thank you, everyone. See you next week, same time. Bye bye.
Thanks, bye.